Hello, saw your question in the email. The mean value of a land building per acre from a sample is $1,500. Standard deviation is $300. The data set's bell-shaped. They want you to use the empirical rule. Assume the sample size is 73. So use the empirical rule, estimate the number of farms whose land and building per acre are between $1,200 and $1,800. So I'm going to open the textbook here to the empirical rule. Here it is, bell shape. Look in here, it talks about the empirical rule. But this picture, they have, the data is bell shaped. The mean is X bar. Within one standard deviation, 68% of the data. Within two standard deviations, 95%. They break it down further here. And so for our specific problem, let's see if I can get where I can write on here. For our particular problem here, the mean's 1,500. So our particular problem, this is 1,500, the mean. That's the middle of our data. And the standard deviation is $300. So the standard deviation is 300. Can't write too well with my mouse. So right here, the mean's 1,500. Now here's one standard deviation to the left of this. So it's the mean minus standard deviation, or 1,500 minus 300. So this value here would be 1,200. Then right here, this would be the mean plus standard deviation. So that'd be 1,500 plus 300. So it'd be 1,800. And that's what they're asking here on this part here. Using this rule, what's the number of farms between 12 and 1,800? Well, from 12 to 1,800 is, within one standard deviation, or 68% of your data. Well, how much data do we have here? We have 73. Sample size is 73. So we want to take 68% of 73. So 68% of 73, that's where they get to 50 at. So if I put that in a calculator, let's see. Oops, can't get my calculator here. So if you took take 0.68, I'm not able to bring up the calculator with this program, times 73. That must, you round the nearest whole number. When you round it, it's going to be 50. That's when it's rounded. It may not be exactly 50, but it says round and around the 50. Hope that helps.